to find a fraction or make a fraction that is larger than 1/2 and put that into the middle of your desk. I want you to find a fraction or make a fraction that is larger than 1/2. When you've got it, give me the secret thumb. You got to be able to name it. So if you can't name it, that might not be a fraction. I'll write the second one. All right, I see quite a few secret thumbs. Michael, what did you come up with? What's a fraction that is larger than 1/2? 2/2. 2/2 is definitely bigger than 1/2. What's another fraction that is larger than 2/2? Will, what'd you get? 2/3. Oh, sorry, I meant 1/2. 2/3 is larger than 1/2. You can measure it. Got anything else? Anything else? I should see it made on your desk. Harper? 4/4 is larger than 1/2. That will work. Victor, what do you need? Not right this second. Give me a second. Okay. Come on. 6/8. Very good. Is larger than 1/2. Jackson?
3/4.
3/4 is larger than 1/2. Very good. Layden, what'd you get?
1 whole.
1 whole is not a fraction.
Oh,
As it is. Did you hear that? I love Layden's thinking. He originally said 1 whole, and I said that's not quite a fraction yet, and he changed it to be something that is still worth 1 whole, and he said 6/6. All right, let's try another one. Move your pieces. This time, make a fraction larger than 1/8. When you've got it, give me a secret thumb. When you've got it, give me a secret thumb. Shelby, you got one bigger than 1/8? 1/4 is larger than 1/8. Shelby, how is that possible? Because 1/8 has the digit 8 in it, but 1/4 has the digit 4 in it. How did that? Will? 1/6 is larger than 1/8. Very good, Bella. 3/3. That's going to take up my whole bar. That's equal to 1 whole. That's definitely bigger than 1/8. Ashlyn? 2/3. Very good. Harper? 6/6, which is kind of hard to say. Yeah, Sean? 2/8 is bigger than 1/8. Very good. Layden?
3/8.
3/8 is bigger than 1/8. All right, let's try smaller than 1/2. Smaller than 1/2.
Oh, that's kind of easy one though.
When you've got it, give me a secret thumb. If you can find more, pull out more. All right, what do we got that's smaller than 1/2? Mason, what do you have? Is that going to be smaller than 1/2? Because I see it, it looks almost like it takes up the same space. 1/4 is, 2/4 is actually going to be the exact same value. So we want something smaller. 1/4 is smaller. Devin? 1/8 is smaller. I love that Devin's got her 1/2, and then underneath it, she's lined up a whole different set of pieces that she can see. Tell me what's smaller than 1/2? 1/6. Think of what is smaller than 1/2? 1/3 is smaller than 1/2. What's smaller than 1/2, Michael?
4/8.
Is 4/8 smaller?
Yeah.
Very short.
Yep. It is. 1, 2, 3, 4. By an inch.
It
No, it's another.
shouldn't be, based on how we cut it might be. But in real life, it's not.
3/4.
3/4 gonna be smaller than 1/2.
I mean 3/8.
3/8 would be smaller than 1/2. That'll work. Bella? 2/6. Very good. Very good. I would like you to make a fraction or find a fraction that is smaller than 1/4. When you found one smaller than 1/4, give me that secret sound. Technically, yes, but we also have to name it. So if we have different fractions, it's going to be really hard for us to name it. So no, that is an equation. I want a fraction. Does that make sense?
1/14.
So 1/14 could be smaller than 1/4. That would be a fraction. That's not the fraction you just told me, but it is a fraction. All right, Shelby, thank you for raising your hand. What is a fraction that you found or created that's smaller than 1/4? 1/8 is definitely smaller than 1/4. What'd you find, Devin? 1/6 is smaller than 1/4. Very good. Lincoln? 1/12. You don't even have that one, but Lincoln knows. Okay, if I'm going to share between 12 friends, it's definitely going to be smaller than if I'm sharing with 4 friends. Victor, you got one? 1/16 is going to be smaller than 1/4. Very good. Gwen? 1/50 would be smaller than 1/4. Are those big numbers or are those small numbers? Small numbers. Very good. Ooh, let's try this one. This one's a little trickier. I now want a number larger than 5/8. 5/8 might be one that you're going to need to build first, and then figure out numbers that are going to be larger than 5/8. When you've got one larger than 5/8, give me that secret sum, please. Got a couple of friends ready to share something larger than 5/8. I love that I'm seeing a lot of 5/8 made on your desk, and then some fractions underneath that. Jacob, what you got? I see you got a good one. 2/2 is larger than 5/8. Very good. Gwen, what you got? 2/3 is larger than 5/8. Very good. Harper, what did you find? 6/6 is larger than 5/8. Very good. Victor? 8/8 is larger than 5/8. Very good. Bella, what you got? 1/6 larger than 5/8?
No.
Where's your 1/6 piece? So we might need more than just one of them. See how many 6 we can have that would be larger than 5/8. You're on the right track, Bella. Mason, what you got? 3/4 is larger than 5/8. Mason, how is that possible? Because I see that if 3/4 you only got 3 pieces, right? But 5/8 you've got 5 pieces. So why is 3/4 bigger than 5/8, but you got more pieces? 1/4 are smaller size pieces? Look at them. 1/4 is bigger. Why is 1/4 bigger? That's kind of tricky. I'm going to open this question up to think about it. I asked Mason, I said, hey, you only have 3 pieces for 3/4, but 5/8 has 5 pieces. How is that possible? how is it that 3/4 is bigger when there's less pieces? Devin, you think you know?
Because you have
Explain that a little bit more. Keep going. So I want to know 3/4. When Mason made 3/4, that was only 3 pieces, 3 1/4 pieces. But when I made 5/8, I had 5 pieces. That seems like 5/8 should be bigger because it has more pieces, but 3/4 was bigger. How did that happen?
because you get
Okay, so Devin said because I have less people or less sections that I'm sharing. Are you talking about in the 4ths or in the 8ths? The 8ths has, in the 4ths has less. So my pieces are going to be bigger. Look at your 3/4 pieces. Go ahead and make 3/4 on your desk. Go ahead and make 3/4 on your desk.
under 8.
Yep. Go ahead and make 3/4 on your desk. So I should see lots of 4th pieces moving. Notice that was only 3 pieces. I have to look at your 8s. Got them. That was only 3 pieces, but yet it's bigger than the 5 pieces that we had for 5/8. How is that possible? How is that possible? Sean, how is that possible?
You measure an 8 and a 4.
Uh-huh.
One is smaller and one is bigger. So even though there says there's more of the 5, since there's 5/8 but 3/4.
Uh-huh.
Like we did with Ashley and Josh, like different, like maybe a bigger fraction.
Okay.
But the 5/8 aren't as big or aren't as big as the 3/4.
Yeah, I love that connection. So what Sean is saying is he said, my fractions are different sizes. 8s are way smaller than 4s. So even though I have a bunch of 8s and not as many 4s, I still have more because the 4s are so big. Think of it like reading a book. If I gave you 8 books, I bet you would kind of freak out a little bit. But what if they were 8 like kindergarten books?
Okay. Oh yeah.
Versus maybe 3 third grade books. Do you see how that's a little bit different? It's worth a little bit different. Lincoln, did you have one that was larger than 5/8? What about a fraction? How could you represent that as a fraction? Because 1 whole right now is a whole number. So I could say 1 once, like this. 1 piece out of 1 piece. All right, let's try. I think I have one more maybe. Ooh, this goes right into what I just had Lincoln do. I want a fraction that is equal to 1 whole. So this time, get out that 1 whole bar. And now I want to find something that is completely equal to 1 whole. When you've got it, give me that secret thumb. I'm going to give some friends some time to find it, to figure it out. What are some fractions that are equal to 1 whole? I love that I see Bella's got it laid out. I see Harper's getting the whole chart laid out. That's awesome. Bella, what'd you find out? 3/3. 3/3 is going to be equal to a whole. I have to sign it, please. Shelby, what'd you find out? But you can't do this. This is illegal. Go give me a pen.
Do you have to write NP?
No, go get a pen.
How is that illegal?
Thirds. What else is going to be equal to 1 whole? Doesn't look the same, but it is equal. Bladen, what'd you get?
I got 12.
12 twelfths. Very good. Michael, what did you get?
6.
6. 6. good. Gwen, what did you find?
Can we do like 2 1s minus 1 1?
So I don't want a whole equation. That could work, maybe. 2 wholes
13
minus
12.
1 whole would equal 1
I'd
whole.
say 13 12. And what?
2 ones, that would be 2 wholes
No,
minus
that's-
1 whole.
But it was saying like 3 12.
Oh, 3 twelfths is not going to be equal to 1
Like
whole.
13 12.
13 twelfths is not going to be equal to 1 whole.
13 12.
Gwen, do you have another fraction that's going to be equal to 1 whole? 2 halves will be equal to 1 whole. Shelby, you got one?
2 halves.
We got 2 halves. Can you think of another one?
4 4.
4 fourths. Very good. Sean, you got one? 8 eighths. Very good. Hey, I'm noticing something. What are you noticing about all those fractions?
They're all just.
Whoa, what are we noticing about those fractions? Because I'm starting to see a pattern. Lincoln, you see that pattern? What pattern are you noticing, Lincoln?
I see like everything is double.
What do you mean by that?
Like there's 6 6 8 8.
Oh, okay, so you're noticing that the numerator is the same digit as the denominator. Is that what you're noticing?
Yeah, that's what are we allowed to do this?
So what Lincoln is asking also is he said, are we allowed to combine fractions? Yes, but that's going to now be an equation, Lincoln. So now you've got 1 half plus 2 fourths. That's how that would repeat that. So I can't just say that's one whole thing if it's one fraction. I can't say 1 half or 1 fourth. That's not the number. But it's 1 half plus 2 fourths. But I don't want an equation right now, but that will work. Yeah. What else are we noticing? Or why do you think that is working? Why do you think the 1 whole, the fractions that are worth 1 whole, have the same numerator and denominator? Why do you think that is? Harper, why do you think that is?
Because there's to make 1 whole there's always gonna be a whole of that number.
Okay, I think I understand what you're saying. Can you explain it to me one more time?
Like if you
Say that again, Harper. I'm sorry.
because
I see.
if you're gonna make a 1 whole, you need the total of all those fractions.
So yeah, let's start with an example. Let's pretend I'm not using my favorite model, I know, but let's pretend I've just split it in half. So to make a 1 whole, how many pieces do I have? To make the whole though.
Oh, you need to.
I need 2 of them, right? I have this half right here and this half right here. That's my denominator. It tells me how many I need to make my whole. And then if I'm going to have the whole thing shaded in, how many pieces is that? 2. It's all of them.
It's all 2. So
It's the whole. My denominator is telling me the number of pieces, and my numerator is telling me how many I'm using or shading in. If they're the same number, then I'm using my whole. Mason, did you hear all of that fun genius that Harper just explained to us? A little bit. You want Harper to explain it again? Yep, Harper, can you do that one more time? But Mason's going to make sure he's really listening.
So,
It's kind of confusing.
if we have like 2 halves and you're sharing it with just you get like both halves of a cookie, and then you'd have a whole cookie.
Do you think it would work with fourths, Harper? All right, let's try and explain it one more time because you're on a roll with fourths. I've cut it into 4 equal spaces. Now what?
If you're sharing it with nobody but you, then you have a whole cookie.
What is my denominator? 4. And then how many pieces would I get if I was trying to take the whole thing?
4.
4. Very good. Awesome. Will, do you have a question?
Yeah.
How do you open these? Yes, you may open them, or do you need help opening them? Okay, just, oh, you got it.
Wait, then there's this.
Oh, I can help you. Just bring it to me, Les. All right, most of us are here. If you're not, you're getting there. Lincoln, don't forget your title. Just a reminder, especially for you, Mason, because I know you're new, we always trace the straight lines that are printed in our notebook. We don't need to draw a crazy line. Just trace the straight line already there, and then that will be our number line. Does that make sense? So fractions live in number line land too. You got one more on the floor, Bladen. Actually, got two more on the floor. I'll get those ones for you. The other one's under your shoe. So just like our regular counting numbers live in number line land. 1, 2, 3, 4, 5. Way down there is 100. Even farther down there is 500. Even farther down there is 6,000. Fractions live in that same land too. Where do you think they are? Where do you think a fraction might be? Our fractions are there. I've made a number line 0 through 10. These are going to be my whole numbers, my counting numbers that I'm used to seeing. I'm just going to label them. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Where do you think my fractions are? Where might they be? Will, where do you think they might be?
In between the numbers.
Why do you think that?
Because a fraction is not a whole number.
Well, it could be a whole number. It could be equal to a whole number, right? We just made some that were equal to a whole number. Could you give me an example of what you're thinking?
Like a fraction could be in between 2 and 3.
Okay. Like what? What might be in between 2 and 3? Is 2/4 gonna be between 2 and 3? Maybe.
2/3 side of 2.
Michael, what are you thinking?
Like there would be like 2/3 inside of 2 and 3.
You think it would be inside 2 and 3?
Yeah, like, and does this also go like what Lincoln was doing when we're adding fractions?
Kind of. Lincoln, where do you think our fractions live on this number line? In the numbers? What do you mean by that?
Like inside of the numbers?
Explain that to me. I think I know what you're saying, but explain it to me so I know for sure.
Well, it's not hard to explain.
It is kind of hard to explain.
Like that's can't really say.
Okay, so are we talking about, let's pretend I have the number 1. Okay, and to make up that 1, I have pieces. Is that what you mean by it's inside the numbers?
Yeah, just like the molecules.
Just like the molecules? Oh.
They build up stuff.
They build up. Interesting idea, Lincoln. I've never thought about numbers that way. Interesting. So you guys are right on the money. Our fractions do live in between our whole numbers. We do know that I can use a fraction to represent a whole number. We just did that. 3/3, 8/8. But in between those whole numbers, hang on one second, Bladen, just so I can get my thoughts down. In between the whole numbers is where I will find fractions. And Will and Michael, you're partially right in the fact that fractions can be in between 2 and 3. I can have fractions in between 50 and 51. It's not going to be the fraction that you gave me, but there are fractions there. Harper, what are your thoughts?
I just got a
Oh, go for it.
like on our Ready Learning game, the game Zoom, it has fractions when you zoom into the number.
Oh, well, yeah. Basically, that's what we're doing. Just like the game Zoom. Who's played that game?
What? We have to.
If you
unlock the levels.
to unlock all the levels. Got it.
Well,
Yeah, when you zoom in really, really closely to those number lines, we start even be able to see those fractions. Now, let's talk about 1 whole. Here's my 1 whole. Where would that live on my number line? It's not a trick question. Would it live at the 1 or the 0? Here's my 1 whole.
In the middle of the 0 and the 1. 1.
Devin, what do you think? Where's that going to live? You think the 0? What is that 1 cookie worth?
1.
Oh, 1?
1 whole. It's 1 whole.
So where would it live on my number line?
At 10, right? No, 1.
Let me ask you this question. How many cookies do I have?
1.
Where is 1 on my number line?
And there's start.
Before the 0.
After the
After the 0.
Do I have 1 labeled here?
Yes.
Y'all are saying some crazy things for a second. There's my 1 whole. Here's my 1 whole. 1 whole cookie. If I was counting 2 whole cookies, where would it be? 2. What if I was counting 10 cookies?
10.
Okay, we're good there?
Yes.
Don't make me a little nervous. But Jacob and I are besties.
mean.
Ashley's face was probably the best. I said that and Ashley goes, oh my gosh. Jacob, Ashley is mad jealous right now that we are besties.
I'm just so mean. Bestie.
Alright, Jacob and I are besties. We are sharing this cookie, and we're going to share it fairly because we're actually good friends. So this is Jacob's side, and this is Miss Miller's side. How much did Jacob receive? How much cookie did he get? Raise your hand to tell me. Raise your hand to tell me how much cookie did Jacob receive? Devin? He got 1/2. Yep, we know that. How much did Miss Miller receive if we're sharing this 1 cookie? Harper? Did I get 2 halves?
No, 1.
I got 1/2. Yep. Now, did I get more than 1 or less than 1? Or did I get 1 whole cookie?
You get half.
Less.
In the middle of 1 and 2.
So, let me back up. Did I get exactly 1 whole cookie?
No.
No. So I know it's not going to be on 1. Did I get more than 1 whole cookie?
No.
No. Did I get less than 1 whole cookie?
Yes.
So we would say that 1/2 is less than 1 whole.
Yes.
Does that make sense? 1/2 of a cookie is less than 1 whole cookie.
Yes.
Let's write that in math language just so we remember. 1/2 is less than 1 whole, which we know in real life. That makes sense. I know if I'm getting half a cookie, but Bladen's getting a whole cookie, assuming they're the same size, right? Remember, Bladen, that matters. Because if I've got a gigantic cookie, my gigantic half could be way bigger than his whole tiny cookie. But we're going to assume they're the same size. Where is 1/2 living on my number line? You already told me it's less than 1. Where is 1/2 going to live on my number line? You already told me it's less than 1. Ashley, what are your thoughts? Okay, so in between 1 and 0? Bladen, is that what your thoughts were?
Kind of.
Kind of, what were you thinking?
I was thinking, like, maybe you could, like, since it's less than 1, but it's more than 0.
Love that language.
So, I thought of, like, say, if you had 1, you would break it in half.
Make it
But you still wouldn't have 0, but you also wouldn't have 1.
So, I love what you're saying. I think we need to zoom in, just like that game. Let's draw another number line, please. Nope, it's going to be same size. It's going to be same size. But instead of 0 through 10, because we know that this fraction is less than 1, but Bladen said more than 0, we're going to go 0 to 1. What? We're going to make our number line 0 to 1, because you guys told me half of a cookie is definitely more than no cookie. But half of a cookie is less than 1 whole cookie.
Wait, this is on Freckle.
Awesome. I'm glad we've seen this. Now that we know that our fraction lives here, where is 1/2 going to be? Where is 1/2 going to be? Shelby, what are your thoughts?
In the middle of the number line?
Why do you say the middle?
Because 1/2 is the middle of 1 whole.
Yes. Say it a little louder for the friends in the back, or in your case, the friends in the front.
1/2 is in the middle of the number line because 1/2 is the middle of 1 whole.
Yeah. If we imagine this number line as like a fraction strip, do you see it as a fraction strip now? We know that 1/2 is going to be right here. There's where 1/2 is going to be, right in the middle. Right in the middle. So if I know where 1/2 is, I know where it can go on my bigger number line, goes right in the middle. If I had my fraction pieces, 1/2 would be here. Do you see it? And then I would have my other 1/2. Do you see the fraction pieces on that number line? You're going to have to wait, please. Wait.
Wouldn't wouldn't 1/3 be like a little bit farther?
Ooh. Bladen asked a really good question. He said, okay, I know where 1/2 is, so where would 1/3 go? Is 1/3 bigger than 1/2? Or is 1/3 smaller than 1/2?
Smaller.
Wait.
1/3 is not bigger than 1/2.
Yes, 1/3 is smaller. Ooh, Ashlyn's giving me some evidence. What are you saying, Ashlyn?
You're sharing with more people.
Yes, 1/3 is being shared with more people. So it's going to be a smaller piece. So 1/3, Bladen, is going to go somewhere over here. Nice. Love that. That's actually what we're going to be thinking about today. Today we're going to be thinking about 3 friends. We got Tom, Marta, and Sean. And they are hiking a trail in the Blue Ridge Parkway. Raise your hand if you've ever been hiking before. Who's been hiking before? What is hiking? Do you think someone can explain what hiking is? Mason, what's hiking?
It's when you hike like with hiking shoes up the mountains.
Okay, can you explain what hiking is without using the word hiking? Like, what is it similar to?
Walking.
Walking. Okay, so I'm going to be walking. I'm not swimming, am I? No swimming. Okay, so hiking is kind of like walking.
Walking outdoors.
It is kind of like walking outdoors. It's probably something you might have had to do if you've been camping before. The Blue Ridge Parkway. Has anyone ever heard of the Blue Ridge Parkway? The Blue Ridge Parkway is in North Carolina. I've been there. You've been there? Super cool. It is in the mountains. Lots of times when people go hiking, they hike in the mountains because they're trying to usually, not always, get to the top of a mountain and then look out and see the view from there.
I saw Grandfather Mountain.
So Grandfather Mountain's a really cool place to go. That is where the Blue Ridge Parkway is.
I'm actually pretty sure my grandma lives somewhere around there.
Oh, super cool. So the trail they're hiking is 1 mile long. Sean, pause that thought. Is 1 mile long. That's a pretty good distance. And along the trail, they took pictures of what they saw. What's something that you're wondering about?
Did they saw?
What's something you're wondering about? Ashley, what do you think? Yeah, I'm wondering how many pictures they took. Wonder if they saw a lot of interesting things. What do you think, Jackson?
What did the two pictures?
Yeah, so they are in the mountains of North Carolina. I'm gonna find North Carolina on my map.
Okay.
We live over here, but if we go over here, you see where it starts to get a darker pink?
Yeah.
That is showing where the mountains are, and this is where the Blue Ridge Parkway is. Yes. It's quite a distance away. It would take a pretty long drive to get there, but you could do it in a day.
It's like 5 hours.
So, what do you think they might see, Jackson? What are you thinking?
A deer?
Maybe they see a deer. That would make sense. Deer definitely live in North Carolina.
Maybe some coyotes.
Maybe. Do you think it would make sense that they saw a cactus? No, cacti do not live in the mountains of North Carolina. Do you think it might make sense that they saw a lion?
No.
Maybe a mountain lion, but definitely not an African lion. Would it make sense that they saw a tree?
Yes.
Did you know that Christmas trees grow in that part of the country?
No.
So would it make sense they saw a Christmas tree?
Yeah.
All right, what else are we wondering? Raise your hand and tell me if you're wondering something. Will, what are you wondering?
Did they see some spirit on the top?
Probably not, but you can see into other states that are much closer. But I'm wondering what they saw when they got to the top. Michael, what are you wondering?
If a bear tried to eat them while they were walking.
Oh, I'm wondering if there was a bear there. Sean, what are you wondering?
Why is there a name?
Okay. Bladen, what are you wondering?
Like what? I don't know, like they're gonna, what did they see?
Sure, could be. Not necessarily.
What they saw, something that like shouldn't be there.
Could be.
What if they did see a cactus?
So here's the stopping points that they had. So at 1/2 of a mile, that means they had already walked half a mile on that trail. They saw a hawk. That would be really cool. Tom stopped and took a picture of that hawk. At 1/4 of a mile, again, they're already walking 1/4 of a mile on that trail. Marta took a picture of a snake. Really? No, thank you. And then lastly, at 3/4 of a mile, Sean took a picture of a deer. So we saw quite a few animals that they took a picture of. What we're going to do is I'm going to give your table group a large-ish piece of paper. We're going to put a number line to show their trail, 0 miles all the way to 1 mile. And then I want you and your table group to decide, where did Tom take that hawk picture? Where did Marta take that snake picture? So you're going to try and figure out, where is 1/2 a mile located? Where would 1/4 of a mile be located? Are there any questions of what I'm having you do?
No.
Okay, so what I need between you and your table group, I need 3 sticky notes. I don't care where they come from, I don't care who gets them out, but I need 3 sticky notes.